Okay, now we're going to go down to example number 3. It says plot and connect the following points. -9, -7, -4, -2, -1, -5, and -5, -5. Give the best name for the polygon and determine the area. So if I go back up to my coordinate plane, I'm going to plot those points and label those, and I'm going to connect them in order. So I have -9, -7, -4, -2, -1, -5, and then -5, -5. I'm going to connect those points in order that they are given, and then go back to the starting point. Now if I look at that shape, it's not a triangle because it has 4 sides, and it's not a rectangle or a parallelogram or even a trapezoid that we studied before. Since it only has 4 sides, we can say that it is a quadrilateral. Quadrilateral means 4 sides. Now the way we're going to find this area is going to be similar to what we did in the second example. Since there's no equation for the area of a quadrilateral, we're going to draw a box around it. But first I'm going to color in the quadrilateral so that I can focus more on that area after I draw the box. K is the leftmost point, and then M is the rightmost point. So if I draw a line, I'm going to draw it like that. Then K is the lowest point, and L is the highest point, so I'm going to draw another side of the box there. And then I'm going to complete my rectangle like that. Now, even this is a little different than what we've been doing in the past. We have a triangle here, A, another triangle, B, but this space down here is not a triangle. So what we can do there is just draw an imaginary line, call that triangle C, and then you have another rectangle. If we subtract those away from the original rectangle, we'll have the area of the quadrilateral. So now I'm going to label my parts. I've got my big rectangle. I have triangle A, triangle B, and triangle C, as well as rectangle D. Now the rectangle, I'll use length times width. Each of the triangles I'm going to use base times height divided by 2. And then this rectangle here, I'll use length times width again. Now if I look at the dimensions of the big rectangle, I can go from corner to corner. I have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8. That means my area is 40 square units of the big rectangle. Triangle A, I'm going to look at, erase this first here. Triangle A, I'm going to go from corner to corner, and now this is my right angle, so that I have to use horizontal or vertical dimensions there. So triangle A is going to have dimensions of 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So if I substitute that in, I get 5 times 5 divided by 2, which is 12.5 units squared. Triangle B is going to have dimensions of 1, 2, 3 by 1, 2, 3. So if I substitute that in there, I get 3 times 3 divided by 2, which means that area is 4.5 units square. And then triangle C down here, I'm going to go from corner to corner. Here's my right angle. 1, 2, 3, 4 by 1, 2. 4 times 2 divided by 2. That area is 4 units square. And then finally I have a rectangle here. The dimensions are 1, 2, 3, 4 by 1, 2. 4 by 2 is an area of 8 units squared. Now for my total, I'm going to take my area of my rectangle. I'm going to use the total up here. The area of the rectangle is 40. And I'm going to subtract away each of those outside shapes, areas. And when I do, I get a total area of 11 units squared.